Hello everybody, so lesson 4. Just so you know, the sequence of lessons that I'm doing is kind of not how I would normally do this, but I thought after 4 lessons you deserved a practical. Yes, a practical, as what my instructions say. You are getting to do a practical. How cool is that? Now actually on a practical, it's Mrs. Lisk is the lady you must thank. So when you go back to school, our technician, thank her because she's the lady that kind of semi-suggested this, because I was thinking, how am I going to do this? They won't have thermometers and what have you the way we do at school. So she said, and she suddenly said, "Oh, why don't try it this way?" And she even tried it. So the picture you will see later is actually Mrs. Lisk's. So yeah, please thank Mrs. Lisk. Again, the instructions are on this slide, as you can see, of what you need to do. So we're just going to get straight into it today. Just any questions as you go through. Don't forget to write them down, email me, and let me know if you have any problems. Let's go for it. So, keywords for today, you have insulation, a method of reducing heat transfer by conduction, convection, and radiation. I then also put down conduction, convection, and radiation just to remind you what those things are. We've done them over and over and over again. So some of my classes have copied conduction, convection, and radiation into their books about 4 or 5 times. You need to know them. You need to know them off by heart. So there's keywords. Get those copied in. I'm going to give you some time. I suggest you pause the slide on the video because I'm going to move on. So get those keywords into your books. They're really important. And off we go. So, insulating a house. Our job today is to analyse and explain which is the better choice to insulate a house. Like, why? And I want you to kind of think about, like, we're generating all this electricity, aren't we? So, the sequence of lessons has been reminding you what energies were, paying your electricity bills, where that electricity comes from, and now we're we're insulating our house to make sure that all that money we spend is saved and spent properly and not wasted on holes in floors and things like that cause heat to leave through because of drafts and stuff like that. So just we're kind of linking into this, and actually what's going to happen is we're going to go back a little bit later and consider sort of some of those bits you've already learned. So we'll talk about reducing the energy loss, how we actually make the energy. Obviously we can't make energy. Bad, I missed off. Obviously, how a generator works and things like that. And then the final thing is we'll just sort of go into a little bit of some energy calculations using gravitational potential energy and kinetic energy, and give you another practical on that to do. So that's the plan there. So we'll have a look at some different insulators, and you guys can do a practical. Let's get on. What 3 ways are there in which you can insulate a house? And what are their effectiveness? There's lots of different ways. You've probably heard of them. You may have seen them. What are their effectiveness? What are the ways and the effectiveness? Are they good, but they may have a problem? Are they not very good? They're etc. etc. So write them down. Give about 5 minutes to think about that. Give some good explanations, the evaluation, their effectiveness. Are they actually any good? 5 minutes, pause the video, and then come back in 5 minutes. It'll be a second for me, but 5 minutes. Go. Okay, so we've now got some ideas to think about. I've given you a few here, and you could probably think of some more. So number 1, double glazing is good. It does reduce energy loss, but it is super expensive. And we did some classes have done payback time before and things like that. We don't have to do that this time. And you don't get a lot of benefit and saving on your bill, your energy bill, for the cost of the double glazing. It could take up to like 20 years for double glazing to kind of pay for itself. And by that time, it may well have perished and you need new double glazing. So that's the other thing is double glazing is only as good as the quality of it. So if you've got, you can start seeing like mist or condensation in your double glazing, then really it means that the rubber seals have gone and the vacuum's gone and there's water in there. It's not going to be as insulating as it should be. Cavity wall insulation is very good, but not all houses can have it. So they tend to drill holes into the cavity between the 2 bricks on the inside and outside of the house, fill that with foam, and that will reduce a massive amount of heat loss through there. But as I say, not all houses are suitable for it, and obviously it costs lots of money. draft excluders. So my house is in desperate need of draft excluders at the moment, but we just don't. It's summer now as I'm recording this, so when it comes to winter, we'll get some because I have got almost sort of 2 centimeters to an inch gap between the floor and some of the doors in my house. It's outrageous, but yeah, we're quite poorly insulated, so I lose a lot of heat from my living room into my kitchen. So you put those sort of like draft excluder things down, like like full of beans or what have you, and you could put them along your door, and they'll just help keep keep the air, the hot air inside your house. Also, shutting doors and things do that in general. And some draft excluders, you get like a sticky strip that then has like some like furry black furry, looks like a mustache almost on it, and they're good. They'll also work. They're cheap, but it also means that the house isn't greatly insulated, just like my house. Right, loft insulation is excellent. It's really cheap. But as an overall, super good value for money. Problems are can irritate the skin in your lungs. So if you need to use your loft for storage, some people then board over it and stuff like that. But in the process, it's not nice and it can cause you irritation. So it's a very 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 good way of reducing heat loss in your house, but can have some drawbacks. Okay. So this slide here talks to you all about different ways you can do it. You can see roof loft, fit loft insulation, windows, get double glazing, use curtains. And it's simple as using curtains will help keep heating. Thicker curtains, right fitting curtains. Some curtains don't fit windows as well as they should do, and they'll cause heat to get lost. Gap seal doors fit draft excluders. We just talked about that. Floor, fit a carpet. Carpets obviously have pros and cons to those. If you've got little children, they get dirty really easily and things like that. Pets hold carpet fur, their fur in their carpets really easily and things like that. But then they keep your house warmer. Through the walls, fit cavity wall insulation. And so they're the main ones. So there are main heat losses in our house. So there's things for us to consider right now. Right, I know. Can you believe you are 7 minutes into this video and you're about to have a practical? Boom. Let's go for it. So let's conduct a practical. Now, when you're conducting this practical, I want you to not worry or panic on this. If you are struggling to do this, please don't worry. What you actually can do is basically Google some data. So I'm going to come onto the slide and I'm going to talk about that, including some of the alternatives to this practical. So you're going to see which of 4 up to 5 materials are the best insulators of ice cubes. So you're going to have the following equipment. Ice cubes. So you're going to need to make some ice cubes. That'll be hopefully quite fun. Or buy some in a bag. You could do that. 3 to 5 different materials. I said 4 different materials, so like I say 3 to 5, whatever's up to you, whatever you can get hold of. For example, foil, black paper, white paper, bubble wrap, cling film, or an old cloth of some kind. Okay, and a stopwatch, and use your phone. I've asked you to write down your variables. So you're going to need to tell me your control variable. You're going to need to up to 5 sets of data. So like I say, 3 or 4 different pieces of material, and you're going to record how long it takes for your ice cubes to melt. So write the method, explain what you're going to do, talk about your variables and control variables, etc., etc. Independent variables, one you're changing, the ones you're going to measure, your dependent variables, go from there. Now, as it says, nota bendes, okay? You don't need to have the same starting temperature for each one. All I just want you to do is, take the ice cube out of a tray or out of a bag, put it on the thing, leave it in the sun. Does it melt? Okay. Now, yeah, this can take a long time if you're leaving it in the sun. So go from there. Do that, or maybe you want to have, maybe you want to weigh them before and after, and which one's lost the amount of mass. This is going to be quite open to you. Okay. I don't mind that it is open to you. You work out the practical as you want to, but as a minimum, you can find a set of data if needs be, and go for it, or just make up some data. All right, and I want you to think about why these different things would be better insulators. Why might foil be a good insulator? Why might black paper? Why might white paper? Why might bubble wrap? Bubble wrap. We talk about insulating in that way. Cling film material. Why might that be better? So I really want you to just sort of go for it on this. Sort of take it upon yourselves to learn something new. So everyone will have a different conclusion. You'll have lots of things. Now, if you are stuck on this, please let me know. If you really can't find data or something, let me know, and I'll send you. I'll find some data. But what this work is normally is it's the hot water in a cup practical, where you'd put a thermometer into hot water in a cup, and you'd wrap the cup in, or a beaker, school beaker, in different material, and see which one insulates the water best and stops the heat loss. So we're going to try it with the ice cubes instead. Here's Mrs. Lisk's example. She did that, and she actually said she found that the black ice cubes were the black material was actually causing the ice cubes to melt faster, because they are absorbing more heat energy and therefore causing the ice cubes to melt faster. So maybe that's the thing you want to do. Is it that the black colouring, you want it to absorb the heat so it stays within your house, or do you want to put foil everywhere in your house to reflect the heat that's lost back into the house? That's why you wrap foil around turkeys and things like that, and chicken and stuff. The bubble wrap, we do know that pockets of air do stop heat being lost and things like that. So try, have a think about it. Right, when you've got your practical data, you are going to need to do a graph, and that will be on your next slide. So on this slide, the graph. I need to draw a graph of your data. So normally this would be a line graph of time versus temperature. Can't do that today, so it's going to be a bar graph. So what I'm expecting is some kind of graph where you have your different materials along the bottom where the bars would start, and then time taken to melt on the y-axis. Or you could do mass change. Okay, so which one has got the heavier ice cube afterwards? The heavier ice cube means it's melted the least. Go from there. You could do it over 5 minutes and then weigh them afterwards. Great. Lots of you have scales and things at home. Do that. It's open to a massive amounts of interpretation, this practical, and it's deliberately designed to do that. Designed to you to come up and be really clever scientists. All right. And if all else fails, like I say, find some data of like a cooling curve data and plot your data on there. Okay. Right, conclusion and evaluation. So create a conclusion for your investigation. Use the data you have collected to decide which material was the best insulation. So literally, which one was the best? Use data in your answer. Okay, use data in your answer. So which one do you think was best and why? Probably the one that had the least mass change or took the longest to melt, that type of thing. So it's keeping the heat inside the ice cube. Evaluation, how could you have improved your practical? I could tell you now, if you look at Mrs. List's one, there are probably some things that she could have improved just there. Okay, maybe you want to think about having the same massive ice cube as you start. Could you do something to warm the ice cubes because it took all day and it got boring, and you ran out of time on your phone or what have you. All sorts of different things. Explain how they could be improved as well. And then a final little sort of challenge evaluation question is, what was your best insulation? Is it any good at insulating a water tank in your house? So would you wrap your water tank in brown or black paper or foil instead of the kind of foamy stuff that it has at the moment? Is that the best thing to do? So what do you think? Would you do that? Would you let your water tank be wrapped in your insulation that you found? Also, I gave you some ideas for insulation. You choose whatever you want. Okay. Right, and then we're on to the plenary. Can you believe 13, nearly 14 minutes in, and that is the end of this lesson today. It's quite a quick one because the practical will take you some time. Okay, so summarise your learning today in a few bullet points. What did you learn about insulations? Thinking about the energy loss. How does it all apply to everything you've done today? What did you learn? And from there, that will be the end of it. It's going to take you longer than 14 minutes. I know this is a short video because you've got a practical to conduct, conclusions to write, evaluations to write, graphs to draw. All right, it will take you a while to do this. Oh, the graph. Don't forget as well on your graph, it doesn't matter if you don't have graph paper, just draw it as you can see. It's only a bar graph at the end of the day. All right, so any questions, please email me, and enjoy this one that you get to have a practical. You will have one more practical towards the end of this sequence of lessons on kinetic energy that I think you'll really enjoy. Okay, so take care, ladies and gents. Any questions, again, email me. Bye.